Okay, let's give you guys some practice. So find the values of x for which this power series will converge. Or another way of thinking about it is find the domain for this function. Same question, but just phrased differently. Okay, so press pause and have a go. Okay, so to do this, use the ratio test. So when it comes to the ratio test, we always need to compute this value here. So it would be an plus one divided by an. So an plus one would be this divided by an. That's the same as multiplying by the reciprocal of an, which would be this. So now tidy this up. So visualize this as x to the power x to the power of n times x. So basically visualize this as this. And then this will cancel out with this will cancel out with this, and then you're left with this. So this is your x, and this is n plus 1. So when it comes to the ratio test, you compute this value here. If this value here is greater than 1, then you know your power series will diverge. If this value here is less than 1, then you know your power series will converge. If it equals 1, it's indeterminate. It's inconclusive. But here, if you look at this here, if you imagine x to be anywhere on the real number line, you can select any number on the real number line. Let's say 900. Well, if you put 900 into the x here, 900. If you put 900 into here, as n tends to infinity, this whole thing here, as n tends to infinity, this whole thing here will head towards 0. So regardless of what x is, the limit as n tends to infinity will be 0. So it will always be, remember, when it comes to the ratio test, if this value here is less than 1, you know your power series is going to converge. But here, no matter what value of x you select, it's always going to be less. Well, the limit will be 0, which will always be less than 1. So you know your power series will always converge, regardless of what value of x you select. So what that means is, going back to the original function, what that means is we are trying to determine what values of x will this series converge. Or another way of questioning the same thing is find the domain for this function. Well, we've just established that no matter what values of x, anywhere on the real number line, so you can select any value on the real number line, it will always converge. Therefore, the domain for this thing is anything on the real number line. So x can be anything on the real number line, and this power series will always converge regardless of what values of x you put into here. Okay.